Hi guys, it's Miss Redigan here, and we're starting percent composition. It's another way scientists count or account for particles. So make sure you're logged into your Jupyter Ed account. You can always pause the video if you need to. Okay, now it should show up here, percent composition intro. If it doesn't, go up to the upper left where the lines are. Go down to, in your case, Regents Chemistry. And it should be one of the assignments right there. You can click on it and open it up. And we do want to write on it, right? We are going to be write directly on the document. Okay. So we're going to go ahead and do this together. I like using the text tool. And we're going to be learning about percent composition. Okay, so the percent comp, I'm going to abbreviate, tells us the amount, really the percent of a certain component within an item. So it's the part you're studying out of the whole thing. Let's take a look at a commonplace percent. So let's say you ate 2 out of the 8 slices. Okay, we can go up and get our highlighting tool up here, and we'll color in the 2 slices that we ate. It doesn't have to be pretty, just gets you the idea. Okay, so let's go ahead and put that in percentage. 2 divided by 8 times 100. If you put that into your calculator, you will get 25%. Pause the video and give it a try. If you don't have your calculator, definitely pause the video and go get one. Now, 25% makes sense. When I look at this visually, you can see that it's 1/4 of the whole pizza pie. Just like a quarter is 1/4 of a dollar. So again, just to be clear how we got the answer, 2 divided by 8. 2 is the part we're studying, 8 was the whole pizza. Then multiply by 100 to turn it into a percentage. Again, feel free to stop the video whenever you need to. Let's look at another kind of percentage, a ratio. So let's say we have 22 students in our class, and that 10 are male and 12 are female. To do the percentage for male, we do 10, the part we're studying, out of the whole, divided by 22. And then multiply it by 100. And I'm going to round to a whole number, 45%. Because you can't have like 0.2% of a person. Okay? Now I can do the same thing, 12 divided by 22 and multiply by 100. Or if I only have 2 items, we know it has to add up to 100%. And that makes this automatically 55%. And then to represent this, we can have every box here worth 10. So let's go ahead and get our shading tool. And I'll make this males. And they have 10, 20, 30, 40 and a half. Okay. And I'll get a different color up here. And we'll do females here. And they have 55. So 10, 20, 30, 40, 50 and a half. 55. Okay. And you can turn those percentages obviously here into a ratio or a bar chart. Okay. Let's look at another scenario. Grades. When you take a quiz that has 10 problems and you miss 3, what is your grade? Well, it's not 3, it's not 30. We care about what you got correct. That's the part you need to study in this case, what you got correct. So 7 out of 10, 7 divided by 10 times 100 gives you 70%. Okay? Again, because we care about what you got correct, which was 7 out of 10. Let's try another scenario. You take a test that has 36 problems and you miss 8. Well, again, we care about what you got correct. So that would be 28 divided by 36 times 100. And you can pause and use your calculator. And I'm going to round, and you should be getting around 78%. Again, 28 divided by 36. Let's put that in terms. Okay, we care about what we got correct. 28 correct answers out of the 36. So we divide. And then you're going to take that, it really should be in parentheses. Let me go backtrack. And then you take that amount and multiply that full amount by 100. Okay. So again, our formula, it's the part you're studying. Sorry about that. Divided by the whole amount. And then times 100. Okay. And the percent composition formula is in table T as well. Make a note. It's always in table T, all of our formulas. Okay, we've looked at percentages in general. Let's take a look at them from a chemist's point of view. Water, H2O, is something we drink every day and is very beneficial, good for us. Hydrogen peroxide has a similar chemical formula, H2O2. However, we cannot drink H2O2 peroxide because it's poisonous. Now compare the percent of hydrogen and oxygen in each particle. So let's start with water. You're going to need your periodic table to do this because we have to use gram formula masses. Right? So we have 2 hydrogens. So I'm going to find the amount of hydrogen is 2. And the mass is 1. Periodic table says so. So that's my numerator. And then I'm going to divide by the whole thing. Well, water is made of the 2 hydrogens, which is 2. Right, 2 times 1 if you want to be specific. Plus an oxygen. We have 1 oxygen, and oxygen's mass is 16. Okay, so just to shorthand that, we have 2 for the hydrogen out of the whole thing, which is 18. That's 2 plus 1, 16. 2 plus 16 is 18. I'm going to do 2 divided by 18 and then multiply by 100. So for hydrogen, its percentage is 11%. Well, if hydrogen is 11%, we know oxygen is the remaining amount, is 89%. Or if you like, you can also go through and there's 1 oxygen, which is 16, divided by 18 times 100, and you also will get 89%. Again, we count the number of each atom, and we also look at their weight on the periodic table. Let's compare that to hydrogen peroxide. Okay, so I'm going to get a different color just to differentiate. Oh, let's see if it'll let me. There we go. Okay, so we know that hydrogen is already worth 1. There are 2 of them. But hydrogen peroxide has 2 of those and 2, and 2 oxygens. And oxygen, as we said, is 16, has a mass of 16. That's going to change our whole. Okay, hydrogen are still just 2. 2 times 1 is 2. Now I have 2 plus 32 for a total of 34. Okay, so again, 2 plus 32 is 34. Now I take that whole amount and I multiply by 100. 2 divided by 34 times 100 gives you a percentage of 6%. So for hydrogen and hydrogen peroxide is 6%. And we can subtract from 100 to find the remainder as 94%. Or we could also just have that there are two 16s, right, which is 32 divided by the 34, and you'll also get 94%. Notice they all have to add up to 100%. Okay, we can draw this in to our pie chart, and we can be very approximate. So 11%, 89%. So let's make, a small amount, that's the hydrogen, and we'll make the rest the oxygen. And I can put little dots. Oh, no, stay here. I put little dots. No, it's not letting me. Okay, let's say I put a little dot next to it. There we go. So I know which is which. Okay, and I can do the same here. I'm going to make that green, and this is a little bit large, a little bit less percentage. I can make that smaller, and then I can still make. Let's make that a little. Okay. And there. Okay, so in water, the percentage of hydrogen and oxygen is 11 to 89%, but in hydrogen peroxide, it's a different percentage of 6 to 94%. And again, that might seem like a small difference, but one is necessary for life and the other one is deadly if we drink it or toxic. So little things make a big difference. Continue with the same process and do the readings for the remainder of the page. Okay? Don't forget your periodic table. Good luck.